In normal matrix multiplication, if M1 and M2 are a 2 by 2 matrix, then their multiplication will also produce a 2 by 2 matrix. The dimensions stay the same. But in tensor product, if M1 and M2 are 2 by 2 matrix, their product will generate a 4 by 4 matrix. Here the dimensions multiply. That is the key idea. Again, the question is why we don't follow normal matrix multiplication here. If you multiply two matrices, you are describing it as: first, apply transformation M1. Then, apply transformation M2. It represents sequential action on the same vector space. Normal matrix multiplication assumes both matrices act on the same space. But when we multiply irreducible representations in group theory, we are not applying one symmetry operation after another. We are combining two independent vector spaces. Here our target is different. For example, if one function lives in space tau 1, another function lives in space tau 2, their product lives in a new space, which is a tensor product of tau 1 and tau 2. That is a completely different space. So we are not composing transformations. We are constructing a representation on a combined space. That requires tensor product. Now, let's understand how matrix multiplication is different from tensor multiplication. Let's see how tensor creates a difference here. Assume we have two irreducible representations, tau 1 and tau 2, and both are two-dimensional representations. Which means each contains two functions, such as A and B in tau 1 and C and D in tau 2 that mix under a symmetry operation. Let's say an operation C2. The character of the irreducible representation for tau 1 is chi1 and for tau 2 is chi2. Since character is the trace of the matrix, let's have two matrix for both the character M1 and M2. Now, we will see what will happen when we are multiplying the matrix. For matrix M1, the trace is A plus D, which is chi1. Similarly for matrix 2, the trace is E plus H, that is chi2. Now, if we perform simple matrix multiplication, then we will have the new 2 by 2 matrix. And now for this matrix the trace will be AE plus BG plus CF plus DH. This trace is not equal to if we multiply chi1 with chi2. Now let's see what happens when we have a tensor product. In tensor multiplication, each element of matrix M1 is multiplied with the matrix M2, which generates a new 4 by 4 matrix as shown here. Now, the trace of the matrix will be AE plus AH plus DE plus DH. This will be same if we multiply chi1 with chi2. And the overall 4 by 4 matrix contains all possible interactions between the two 2 by 2 matrices. Again, to determine the tensor product of two matrix, we don't need to use the whole matrix. We can get the same information if we simply multiply the character or trace of the individual matrices. This becomes very useful in group theory, because by multiplying characters of each irreducible representations, we can able to get the information about all possible interaction. In next video we will see how this becomes very useful in determining the transition moment integral.